Welcome. This recording is for Sample Work 7 for Geometry A, Unit 7 Sample Work, all about triangles. So let's go ahead and get started. You're going to want to write down each word, write the definition, and sketch the examples. You can come up with your own examples, and you can write the definition in your own words if you like. But this is meant to serve as kind of a guide. First word is mid-segment of a triangle. Mid-segment. Okay, of a triangle, I'm going to leave out of a triangle. It's kind of assumed this is a unit about triangles, but mid-segment, particularly of a triangle. And a mid-segment is a segment connecting two midpoints. Okay, and I'm going to sketch triangle. I'm going to sketch the midpoint of one side and sketch the midpoint of the other side. We'll mark that that's the midpoint by indicating what segments are congruent. And the mid-segment connects those two midpoints. Mid-segment. Distance from a point to a line. Distance from a point to a line. Point to a line. It's the length of the segment, or I should say the length of the perpendicular segment. We'll use the symbol for perpendicular. Connecting a point to a line. So, example, here's our line, here's our point, call it P, the line L. The distance from a point to a line is the length of the segment from P to L that makes a perpendicular or right angle to L. And maybe this is 15 inches. Distance from a point to a line must be measured on the perpendicular. Equidistant. Same distance. An example from this unit, if I draw an angle bisector, or if I draw an angle bisector, every point on the angle bisector is equidistant from the sides of the angle. That is, these two segments are the same length. Okay, let's label these A, B, and C, and we'll indicate AB is congruent to BC. They are the same length. They are congruent segments. Circumcenter of a triangle. I'm going to leave out the of a triangle here. Circumcenter. The concurrence. Concurrence is a word meaning all at the same time, the same place. The concurrence of the circumcenter perpendicular bisectors. Example, I have a triangle. I'm going to sketch the perpendicular bisectors of the triangle, and they all intersect at the circumcenter. Okay, it also happens to be the center of the circumscribed circle. That is, if you draw a circle with that center and it touches one vertex, it will touch all three vertices. It goes with, by the way, the equidistant idea, because every point on the perpendicular bisector is equidistant from the endpoints. Circumcenter. Concurrence of the perpendicular bisectors. Concurrent. We've been using this word. Now we're going to define it. All at the same point. So these three lines are said to be concurrent because they all cross at one point. In center. I'm going to leave out the of a triangle here. In center. The circumcenter was formed by the perpendicular bisectors. The in center is the concurrence. Of the angle bisectors. So if I draw a triangle and draw the angle bisectors, so it splits each angle exactly in half, they meet at the in center. And the in center is, if I draw a circle at the in center, and it just touches one side, it'll touch all three sides. It's called the inscribed circle. So the in center is the concurrence of the angle bisectors. Inscribed in. Okay. The largest that will fit inside, just touching all three sides. Okay, and I'm going to give this as my example. This circle is inscribed in the triangle. It just touches all the edges, all three sides. Inscribed. Okay, and it doesn't have to be three sides. You can talk about a shape inscribed in any shape, and it doesn't have to be a circle. But it's the biggest of that type that'll fit inside. It just touches all the sides. Okay, inscribed in. Point of concurrency. Point of concurrency. A point shared by three or more objects. For the point of concurrency, I'm going to refer to the previous example we used and draw an arrow. That's a point of concurrency. Then concurrent. Misspelled that. Altitude of a triangle. I'm going to leave out the words of a triangle. Altitude. And particularly of a triangle, so this has nothing to do with airplanes. Altitude. A line from a vertex perpendicular, so I'll use the symbol for perpendicular, to the opposite side. So in a triangle has three altitudes perpendicular to the opposite side. So it's drawn so that it is perpendicular to the opposite side. Note that there's one there. There's one here, and there is one right here as well. And they are concurrent, and the point of concurrency is called the orthocenter. But it's a line from the vertex perpendicular to the opposite side. Notice it doesn't split the side or the angle in half necessarily. Okay, time to make a little bit of room here. altitude. Don't give me any altitude, man. No, that's attitude. All right, centroid. Centroid. The centroid is the concurrence, point of concurrency, or a concurrence of the medians, which we haven't defined yet, but we will just shortly. Okay? So in a triangle, find the midpoint of a side and connect that to the vertex, the opposite vertex. Find the midpoint of the side, connect that to the vertex. Midpoint of a side connected to the vertex. And that forms something called the centroid. Okay? Medians, or median of a triangle. Okay, a median, it connects a vertex, that's a corner, with an opposite, with a midpoint, And for an example, I'm going to refer to the lines I drew here. Median. And orthocenter, last word. We're almost done. Orthocenter. And that's the concurrence of the altitudes. And it's really important in this unit that you get straight all four of these words. Orthocenter, centroid, incenter, and circumcenter. Okay, and what they're formed by. Okay, but the example here is right there. It's the concurrence of the altitudes, and the altitudes are lines drawn through a vertex that are perpendicular to the opposite side. And that is it.